Lesson 19.4, Properties of Similar Figures or Similar Polygons. So let's do a quick review first. Similar. Remember that this squiggly is the symbol for similar. So anything that is similar, they have the same shape, but different size. So with similarity, a lot of times the transformation is a dilation, which means a reduction or enlargement. Congruent, which is an equal sign with a squiggly on top, means the figure has the same shape and same size. So with congruency, your transformation can be a combination of translation, reflection, and or rotation. We also talked about proportion in our previous lesson. Proportion is basically setting two fractions equal to each other. So it is an equation that equates two ratios, and ratio is just another word for fraction. So I'm writing this in general. So if you have a fraction that's a over b equals c over d, then you could cross multiply which means a times d equal b times c. Okay, so you're moving from here to there using cross multiply. If you have a over b also equal to c over d, again, we're still comparing two fractions. And if we flip each of the fraction, as in using its reciprocal, which means a over b is going to become b over a, and c over d is going to become d over c, then the reciprocal of that must also be true, right? So from the first set to the second set, the reciprocal, which is that's what's going on, must also be proportional. So next, quick refresher on solving proportions. So for example, if I have 4 over x equals 5 over 9, I could cross multiply. So it's going to give me 5 times x equals 4 times 9, which is 5x equals 36. Solve for x, divided by 5 to both sides. The 5 will reduce to just x. So x is equal to, what's 36 divided by 5? If that doesn't go into evenly, leave it as 36 over 5. And that would be your answer. Okay. So again, going back to the reciprocal of proportions, I'm going to show it to you here on the side. If we take the reciprocal of 4 over x, which means x over 4, equal the reciprocal of 5 over 9, which is 9 over 5, we could also solve for x in the same manner using cross multiplication. We're still going to get the 5 times x and the 4 times 9. Okay, so we get 5x equals 36, and divided by 5, you get x is equal to 36 over 5. So still the same thing. Okay, so let me go back to the left side here. The 5 times x, right, so the result's there, and the 4 times 9, the result's there. Okay, so the same goes on the right hand column. All right, so as you can see, I'm showing 2 different way, in a sense. The 5 times x, I'm going from the bottom left to the top right, but the 5x is on my left side here on the first column, and then on the second column, I did the 4 times 9, but my answer is on the right hand side. So either way, it's going to work. All right, you just need to decide which direction you're going to go. Okay. All right, example 2. So if I have x plus 4 over 3 equals 7 over 8, first thing you need to do is when you see a plus sign or a minus sign, you need to add parentheses to that. All right, so make a note to put parentheses when you see a plus or a minus sign in any part of the ratio. Okay, so now we're going to go ahead and cross multiply. Pay attention to the x plus 4 because it's being multiplied by 8. A lot of times students just do this, 8x plus 4. This is wrong. Okay, this is why we put that parentheses. So you want to write out that step, which is 8 times x plus 4. Okay, so remember that parentheses right there. This is an important step. Do not skip it, because if you skip it, you're going to get the wrong answer. 3 and 7, that's 3 times 7. This is where we need to distribute the 8 into the x and 8 into the 4, which gives us 8x plus 32 equals 21. Solve for x the same way we know how to solve for x. Subtract 32 to both sides. 8x equals negative 11. divided by 8 to both sides. X is equal to negative 11 over 8. Because 8 do not go into negative 11 evenly. We're just going to leave it as a fraction. It's simple as that. Alright, moving right along. Section 2. Writing similarity statements. And I'm going to abbreviate statements. So I'm going to draw a quadrilateral here. A, B, C, and D. So do your best in drawing it as similar as possible. All right. E, F, G, and H. All right, so we are going to identify the angles. Angle A is going to match with angle E. Angle B is with F. All right, so pay attention to the tick marks. All right, so A is a single line, B is double, C is 3, and D is going to be 4 of them. So the same goes for E, F, G, and H. All right, so that way we know those angles matches. So these are similar quadrilateral. So A, B, C, D, quadrilateral A, B, C, D is similar, you got to use that symbol, to quadrilateral E, F, G, and H. All right, so here we could indicate that angle A is congruent with angle E. Angle B is congruent with angle F. Angle C congruent with angle G. Angle D congruent with angle H. So all these angles, the angles are congruent because they have the same measurement. So because they have the same measurement, all right, so if we compare the side lengths, all right, so let me bring it back down, and you have to match it as well. So AB, side AB, all right, so I'm the way it's being highlighted, it's a little bit over, okay? It's congruent to side EF, just to make sure that it's visible to you, okay? So if you take side AB, which is on the left side, then you need to match it with your other similar object, make sure it's the same thing, right? So we're comparing with, starting from angle A, which is a single tick mark, to the double tick mark. We're doing that side length right here, okay? The same goes for EF, starting with the single tick mark angle, going to the double tick mark. We're comparing those two side lengths, all right? So the way we write that is exactly the way it's being indicated. Side length AB over EF, right? And if we continue to go around the diagram, it's going to be BC over FG. Okay, let me bring it down. So BC over FG and CD over GH and DA over HE. All right. So we just compared all the side lengths to show proportions. Okay. So let's write that down. We compared all the side lengths to show proportions. Now, you have to keep it in the same ratio, in the same format, okay, with every single side length that you are comparing to. So what does that mean? That means for all of these, I started out with the large figure over the small figure, right? I start out with my large diagram, which is the one that's in light blue, and I compare it to the small one, which is the one in purple, okay? And so if you look at all these fractions or ratios that I'm comparing, AB over EF, AB belonged to the large figure, EF belonged to the small figure, and I gotta do the same thing for every single side length, all right? All right, so next, we have a theorem here. So theorem is a property that's been proven to be true, which is also a rule that would help us with geometry. Okay, so the theorem is saying if two polygons are similar, then the ratio of their perimeter is equal to the ratio of their corresponding side lengths. All right, so what does that all mean? This is exactly what it means. If you take all the side length measurement, so side length AB plus BC plus CD plus DA, and again we're doing large over small, all over to the small side length EF plus FG plus GH plus HE, it will have the same ratio with what we just compared for the side lengths separately. And that's how we know that those two polygons are similar. Okay? All right, next, comparing polygons. Compare similar polygons. So if I have a triangle here, A, B, and C, and again, objects are not drawn to scale. D, E, and F. So we're trying to figure out side DF, right? So DF is what? So we need to think about which of the side we want to use as a ratio. Okay, so we could take side BC over EF. Okay, so again, I'm comparing, let me back up a little bit. I'm comparing large over small. Right, so this is large triangle, small triangle. If I'm taking side BC over side EF, so then the measurement is 6 over 4. It's being reduced to 3/2. And I need to check all the other sides. Side AB over DE, and AB is 9. DE is 6. If I reduce that fraction, that becomes 3/2. So what does that mean? That means for these two, I have a scale factor of 3 over 2. So what does that truly mean is that if I am trying to figure out DF, so I need to take AC over DF. AC is 7, DF is X, and the scale factor is 3 over 2. I could use the scale factor to help me decide what in the world is X. So cross multiply, and I get 3x equals 14 divided by 3. X is 14 over 3. Okay, so my solution for DF, so the measurement for side DF is 14 over 3. Now, that's not such a nice number, and it doesn't have to, but that's the answer.